Hello everybody. Today we're going to take a look at type 2 ionic compounds. Type 2 ionic compounds come from metals that are in the transition metals family. If you take a look here, we have two different compounds. You can see that they are differing in color and kind of the texture. The black looking compound is FeO, and the red looking compound is Fe2O3. According to the rules that we learned for type 1 ionic compounds, which is what we did last week with fixed charges, they would both be called iron oxide. So when you look at the two substances, you can see they're clearly different. So obviously, calling both of them iron oxide doesn't really help us differentiate between them. When you look at the two different formulas, we have FeO and Fe2O3. They both have iron and oxygen in them, but they're in different ratios. For FeO, there's one of each atom or ion, and in Fe2O3, there are 3 irons and 2 oxides. So you can see that there's clearly something going on with the transition metals. Otherwise, these would both be called iron oxide. The transition metals are found in the middle portion of the periodic table, and there's no clear patterns like we saw with the other groups that we've been dealing with. For example, group 1, we notice that there's a pattern. They all have a +1 charge, etc. The transition metals are different, and the reason for this is because the transition metals can maintain or have multiple oxidation states. What's an oxidation state? All it means is that they can have more than one charge. That's it. So if they have multiple oxidation states, that means they have multiple charges. The transition metals don't only lose a set number of electrons. Sometimes they might lose 1, sometimes they might lose 2, depending on the situation. Okay, so we're going to investigate this a little more. Copy down these two questions, and then we'll go into them a little more detail. Got them? Great. So we're going to start by looking at this compound up here, which is Cu3N2. And when we look at the periodic table, you'll notice that copper is number 29 here, okay, which is in the transition metals. Remember, the transition metals are found here. Now, these transition metals, remember, they have more than one charge. They don't follow any pattern. Remember, all the group 1 that's over here, they all have to lose 1 electron, so they get a +1 charge. All the group 2 have to lose 2 electrons to become stable, and they have a +2 charge. All of these have, a +3 charge, a +4 charge. But the ones in the middle, the transition metals, they have more than one charge possible. So because those transition metals, remember, in the middle, don't have a particular pattern, we need something else. So what we have here is a table of a bunch of common multivalent electrons. That basically just means, elements, which basically means that they can have more than one charge. Okay, so this table is here for you as a reference. Okay, so we're going to take a look at this table here, and we're going to look up copper. So here's what I want you to take a look at. Copper can be right here, okay, which is copper 1 or cuprous, or copper can also be copper 2 or cupric. So those are two different names. We need to figure out which copper this is. Okay, so to figure out which copper that we have, either the +1 copper, which is here, or the +2 copper, which is here, what we have to do is we have to end up looking at the nitrogen that's over here. Okay, so we're going to take a look at nitrogen. Nitrogen is over here. It's in group 15. It has 5 valence electrons, which means it wants 3 more. So it has a -3 charge. Remember this column. Remember, we just count from the noble gas column and we go to the left. So it's a -3 charge. Okay, so now that we know that nitrogen has a -3 charge, so I'm just going to write that, and we know that it has 2 nitrogens, we can look at the total charge here for the nitrogens. So what's the total negative charge? If you said -6, you're correct, right? -3 and -3 is going to give us -6. Okay, the second part of the puzzle that we have, because basically that's what this is, right? It's a puzzle. We're trying to figure something out. We have 3 coppers, right? Okay, so that means I have Cu 3 times. Now we know that every compound has to be electrically neutral. That means we need the same amount of positives and the same amount of negatives. So if we have 3 coppers, that means they need to add up to a +6 charge, right? To cancel out the -6 charge. So when we think of it this way, okay, I need a +6. +6 divided by how many coppers do I have? I have 1, 2, 3. 6 divided by 3 is 2. So each one of these coppers has to have a +2 charge. Okay, if you have a question about that, please make sure you ask. Now that we know which ion we have, we can name this compound. So in order to name it, all we got to do is look at this table here. So we're going to look at the copper +2. So that's going to be right here, copper +2, which is copper 2 or cupric. And then we just name our compound. So we end up with, just going to erase these and get it out of the way. We end up with copper 2, copper, Roman numeral 2, and then the N is still going to be nitride. Okay, we don't change anything about the second part. So the nitrogen, we drop the gin part and change it to IDE. So the name of this is going to be copper 2 nitride. Okay, so the second example we're going to do is SnO2. And when you find SN is found over here. It's number 50, it's tin. So while it is not technically a transition metal, it is in group 14. And remember, group 14 has 4 valence electrons, which means it either needs 4 more electrons to gain a full shell of 8, or it needs to lose 4 electrons. So it's kind of right there in the middle. So it behaves sometimes like a transition metal. So tin can possibly have more than one charge. Okay, it might have a +2 charge where it gives away 2 electrons, or it may give away 4 electrons and have a +4 charge. Lead, which is right below it, also behaves in the same way. So it behaves like a transition metal. Okay, so in order to name this SnO2, it's made up of tin and oxygen. We have to, again, just like we did with the previous one, we have to look at the nonmetal. In this case, it is going to be oxygen. So when we look at oxygen, oxygen is up here in column 16, and it has a -2 charge. Remember, that one has a -2. So this is telling me that I have a -2 charge, and this little subscript tells me I have 2 of them. So I've got O -2, but I've got it twice. So we have to look at the total negative charge first. So what's -2 plus -2? If you said -4, you are correct. So now we have to look at tin. So if I look at tin here, okay, that's Sn. And how many tins do we have? Well, we don't have a subscript, so we only have 1 tin. What does the charge of that tin need to be to cancel out this -4? If you said +4, you are correct. So this is going to end up being a +4 charge, right? Because again, it has to be neutral. The positives have to equal the negatives. So to name this, we're going to take a look at our chart here. Let me just put it right up here. And I'm going to try to find tin. So when I look at tin, I have tin and the charge is +4. So I'm going to look under the +4 column. This is what I'm going to use. So we're going to name this tin 4, which is IV in Roman numerals, oxide. Okay. You could also name it stannic oxide as well. Either is correct. I usually use the Roman numerals, but if you prefer to use the stannic, this is just the Roman part, you can say that word instead. Okay, they both mean the exact same thing. Okay, so I want you guys to try these 5 problems. Okay, you've got the periodic table here to help you out. These are all transition metals. So remember, you always have to look at the non-metal first before you can figure out what the charge of the metal is. Good luck, and if you have any questions, let me know. Make sure that you upload your picture of these problems and your notes to the assignment today. Okay, and if you have any questions, of course, ask.